Okay. Hello everyone. So in this video we will talk about inferences for two memes. Okay. So let's take a step back. So remember what we did so far. So in the previous slides we talked about the confidence intervals and hypothesis testing for single mean mu. Okay. So remember mu was the parameter of the population. Okay, so it was the parameter of the population, and most of the time we never know it. What we do is we just take a sample, right, a small number of observations people from that population. For example, the population can be the students in the university, and the sample is the students in a class, in our class, for example. Then we just take a sample, which we call the X bar. So this is the average of the class, and using the sample mean X bar, we just make hypothesis testing and remember confidence intervals in order to extract or infer information. Okay, infer information about the unknown parameter sigma. Sorry, unknown parameter mu. Okay. So how do we do this? Remember, we said that what X bar is approximately normally distributed using the central limit theorem with the population mean mu and with, let's say, variance sigma square divided by n. Okay, so this is from where? From central limit theorem. If sigma is known, okay, if sigma is not known, then what we know is that so this also means that X bar. So let me just erase this. Um, okay. So what does this mean? This means x bar minus mu divided by sigma divided by root n is approximately standard number, which is 0 and 1. Okay. Another version of this is when you don't know sigma. So it means x bar minus mu divided by, let me just write it here, s divided by root n. Okay. S divided by root n. This is t distributed with n minus 1 degrees of freedom. Okay, so you don't know sigma. Instead of sigma, you just use s, provided that the population itself is now normally distributed. In order to use central limit theorem, recall that we don't need any particular assumption for the distribution of the population itself. Okay, so this is what we did up so far. Now, uh, so for example, if you are dealing with the height of the population, okay, so you just want to test whether the height is equal to 170 versus mu is not equal to 170. So that, for example, assume you are just trying to design a seat for the students in the university, or you may just again just check whether mu is equal to 75 kilograms, whether the average height of the students is 75 or not. Again, you want to, I don't know, design um, a kind of a shoe, okay, for the general students population in Turkey. So you just want to test whether their average height, sorry, weight is equal to 75 or not. But for this case, okay, now from now on we will talk about two populations, okay, two populations. So we will deal with uh, two populations parameters, which is mu1 and mu2, okay. And in general, what we will deal with is we will deal with their differences. Okay, so what are some examples for this? For example, I want to see whether the, let's say this is mu1, let's say for example the height of male students, okay, male students, and mu2 is the height of the female students. And I want to check whether the height of the male students is, let's say, 10 centimeters taller than the height of the female students. Okay, so this can be my let's say point of interest, or let's say mu1 can be equal to the average GPA of, sorry, the GPA, okay, of again male students, and mu2 is the GPA of the female students. So I want to test whether male and female students has the same GPA or not. Okay. Or we will have an example for this. Let's say mu1 is the fuel consumption of a car and mu2 is fuel consumption of another car. I want to test whether the fuel consumptions of these both type of cars are equal to each other or not. Okay? So what I'm interested in now, okay, for in this chapter is that I'm interested in two populations means, in fact. Okay? Whether in most of the time I'm interested in whether they are equal or not, but I may be interested in some cases so that, well, whether mu1 minus mu2 is equal to, for example, let's say 15 centimeters for their height, or mu1 minus mu2 is equal to 0.5 liters per kilometer. Okay, so I may be interested in this kind of differences as well. So in this chapter we will talk about this, and in the next slide we will continue with talking about this inferences.